Here we are at example 9 from the 0.2 number 2 set of notes. We are asked to graph this following rational function. And let's just go ahead and kind of run through, for example, like finding our vertical asymptote first. We know that we go ahead and set the bottom not equal to 0. So we have x squared, this is for our VA. We have x squared minus 4 is not equal to 0. And then we can just go ahead and solve from this. There are a couple ways that you can go ahead and do that, but I think the quickest and easiest way is just to add 4 to both sides and then take the square root. So the square root cancels with the square, leaving us with just x is not equal to, the square root of 4 just comes out to be 2. But anytime you take the nth even root on both sides like that, you have to introduce that plus minus, so please don't forget that. We should then see some vertical asymptotes then at -2 and +2. So there's -2, here now is our +2. Now the vertical asymptotes really just kind of cut things into different pieces. So for example, because we have 2 vertical asymptotes, we're going to then have 3 different sections that we're looking at. Let's go ahead though, before we find those 3 different sections, let's go ahead and find out what is our horizontal asymptote. Well, we are in the scenario where the degree on the bottom is larger than the degree on the top, and as a result, we do end up with then just y is equal to 0, that horizontal asymptote. Now looking at slant asymptote, well, unfortunately we really won't have a slant asymptote because it doesn't really follow our definition where the degree on the top is larger. So we actually won't have a slant asymptote for this particular problem. Now looking at x-intercepts, if we go ahead and set the this g of x, which is the same thing as saying y, equal to 0, we can go ahead and find out what our x-intercepts are. So we have 0 is equal to x minus 1. Again, just really using that trick where we just set the top equal to 0. So then we should see an x-intercept occurring at 1. So again, an x-intercept is actually a point, not a line, which is what we have right now. And as a result, we need a point. So our x value happens to be 1. Our y value for x-intercepts will always be 0. Now, if we're trying to determine what is a y-intercept, all you have to do is plug in 0 for x and determine what is that corresponding y value. The reason why we're plugging 0 in for x is because if we're trying to determine where is it crossing this y-axis, well, you're not going to the left or right any for x, it's literally 0. And that's why we can go ahead and plug in 0 for x. So when we do that, we end up with just 0 minus 1 is -1 on top. So when we do that, we just end up with 0 minus 1, which is -1 on top, over 0 squared is 0, minus 4 just comes out to be -4. So our y-intercept, at least the y value, comes out to be 1/4. And again, that is actually a line. We need a point, just like the x-intercept. So our x value, we mentioned before, was not moving left or right any. So that's why it just comes out to be 0 for that x value. Our y value just came out to be 1/4 though. So now going ahead and graphing our x and y-intercepts, we end up with a point here. And that's our x-intercept. Our y-intercept happens to be a little bit above. I'm going to show it just closer to a half so you can kind of see that it's just a little bit above that horizontal asymptote. Now you might be thinking to yourself, well, wait a second. We have a horizontal asymptote. It's clearly this x-intercept is on that horizontal asymptote. What's going on there? Well, again, x-intercepts can happen that way where they end up crossing a horizontal asymptote. It doesn't have to be an x-intercept though. But we can see some potential crossings of horizontal asymptotes, just horizontal asymptotes. Doesn't quite work for vertical asymptotes, all right? So now if we go ahead and check out why that works, we realize that our horizontal asymptote from before was 0, so that y value was 0. And it turns out, just when we found our x-intercept, it actually comes out to be the exact same point. So it can cross there with that horizontal asymptote. Again, we can actually literally see it crossing because we literally found it here when we were trying to find x-intercepts. They happen to actually be the exact same point. Now let's go ahead and actually take out the graphing calculator to kind of fill in some of the rest of the pieces of information. You know, it's really nice to be able to use the graphing calculator because on that AP exam you will be able to use it for certain parts. Let's go ahead and graph this particular function. We're going to always start out by, anytime you have a rational function, we're going to open it up with a parenthesis and enter that top piece. So we end up with x minus 1, x minus 1. We're going to close that with a parenthesis and then have our division with the bottom polynomial. So we have x squared minus 4. X squared minus 4. And there we have correctly entered our function into the calculator. It's very, very critical though that you guys keep in mind that those parentheses. We're going to go ahead now and graph this. And this is the image that we end up seeing. So we see that to the left, we still have these vertical asymptotes at -2 and +2, so that kind of confirms what we have. To the left of that vertical asymptote, we are seeing that it's below that horizontal asymptote. And then also in the middle, we do see that it's a fourth at 0. It is crossing our x-axis at 1 and then does go down. And then to the right of our vertical asymptote of +2, it's above our horizontal asymptote. So let's just go ahead and look now at the table just to kind of see what's happening there and make sure things are actually matching up. So we do see an error. Oh, we got to change up some of our values so that we can see some of those negative x's. So we're going to go and hit second table set. And we want to set up our table starting at like -10. We're going to go by ones. That's a typical like table value. And now if we just hit second table, we're brought back to this table menu. And then we can see that these are the values below that vertical asymptote -2. And we actually then see at -2 that error sign, that error symbol. And the reason for that is because we have a vertical asymptote there. Now just going down. Even at 0, we notice that we ended up with a fourth. At 1, it's 0. At +2, that other vertical asymptote, it's that error sign again. So again, these are just a bunch of, just different values that you can have for your table. But it's important to really know how to use your table with your graphing calculator. Just want the graph. So we should see an image that looks something like this. So just graphing now, we should see something. Again, this is just going to kind of be a rough sketch. Of what our graph would look like. So again, that is example 9 from the 0.2 number 2 set of notes.